Title of the first section today is Dividing by a Monomial. In this section, we'll divide by a monomial. Monomial only has one term. First question, 9a cubed b squared minus 18a squared b cubed divided by 3a squared b. To divide by a monomial, which again only has one term, we will take this by monomial and divide it by each number and each term in the numerator. So we'll divide 9a cubed b squared by the monomial, and we'll also divide negative 18a squared b cubed by the monomial. Dividing this out, the first term, we can divide the coefficients, 9 divided by 3, which would be 3. A cubed divided by a squared. If you remember in previous sections, when we divide like bases, we'll subtract the exponents, 3 minus 2, which would be a. And b squared divided by b, subtracting the exponents. If you want to, b can be b to the first. 2 minus 1 would also be 1. So our first term will have 3ab. Bringing down the minus sign for the second term. And again, dividing the second term by the monomial. 18 divided by 3 would be 6. A squared divided by a squared. If you subtract the exponents, you'll get a to the 0 power. A to the 0 power is also 1, or we can leave it off. And b cubed divided by b to the first. Subtracting the exponents, we'll add b squared. So our final answer, 3ab minus 6b squared. Second question and last question for the section. First term in parentheses is 18x squared y plus 27x cubed y squared z, and close parentheses. Outside parentheses, we'll have a second parentheses, which will be 3xy raised to the negative 2 power. Looking at this question, it looks like we're multiplying two parentheses, but if you remember, negative exponents means we'll take the reciprocal of this expression. So what we can do is make the first term a fraction, and instead of multiplying by a term to the negative 2 power, we can rewrite 3x squared, 3xy in the denominator, and changing the negative 2, we can change it to a positive 2 after taking the reciprocal. So instead of 3xy to the negative 2 power being multiplied, we can divide by 3xy squared on the outside. Before we divide by the monomial, we have to simplify this first with the parentheses. If you remember, the square will go to each number and each term on the inside. So simplifying just the denominator, 3 squared would be 9. X will have a exponent of 2. And y will also have a exponent of 2. So instead of dividing by 3xy, we'll be dividing by 9x squared y squared. Simplifying from here, we'll have 18x squared y divided by 9x squared y squared. 18 divided by 9 would be 2. X squared divided by x squared would divide out, or would be x to the 0, which would be 1, so we'll keep the 2. And y divided by y squared, if we put an exponent on here, y to the first divided by y squared, subtracting 1 minus 2, will give us y to the negative 1 power. Plus the second term, 27 divided by 9 would be 3. X cubed divided by x squared, subtracting the exponents, we'll have x. Y squared divided by y squared would cancel out, and we'll have a single z left over. Simplifying from here, when we have negative exponents, we can rewrite this using a reciprocal. The 2 would stay the same since it does not have a negative exponent, but y to the negative 1 we can put on the denominator, changing to a positive 1, or we can also leave the 1 off. Plus 3xz would stay the same. So our final answer, 2 over y plus 3xz. Title of the last section today is Dividing Using Long Division. In this section, we'll divide polynomials using long division. First question is a question without variables. 101 divided by 3. Taking these two numbers, we can divide them using long division. If you remember, for long division, the number that goes inside is the numerator, which is 101, and the number we're dividing by, or the denominator, goes outside the dividing sign. Dividing from here, 3 doesn't go into 1, but 3 will go into 10. 3 goes into 10 3 times, and then we'll multiply 3 times 3, which would be 9. After we multiply, if you remember, we'll subtract. 10 minus 9 would be 1. And after we divide, we can drop down the next number, which would be 1. 3 into 11 would also go 3 times. And again, multiplying 3 times 3 would be 9. Subtracting, we'll have 2 left over, or a remainder of 2. Instead of putting zeros up here and dropping down more numbers, we can use this 2 to write a fraction. If you remember the fraction remainder, the remainder number left over is your numerator, and the number we're dividing by 3 would be the denominator. So 101 divided by 3, our answer would be 33 2/3. Next question, we'll do the same process, but we'll use a polynomial which has variables. Next question, in parentheses, x cubed plus 8x squared minus 20x divided by x minus 2. From here we can set up the long division problem and divide, but instead of just numbers, we'll have variables to divide. Again, we can set up the long division symbol. The numerator, or top part of the fraction, we'll put inside x cubed plus 8x squared minus 20x. And the number or term we're dividing by, x minus 2, we'll put on the outside of the dividing symbol. To divide, x will take the first number, and x cubed also take the first term, and we'll divide x into x to the cubed, or you can think about x times what number would be x cubed. In this case, we'll have x squared, because x squared times x will be x cubed. So when we multiply x squared times x, we'll put x cubed underneath the x cubed, but we'll also distribute. X squared times a negative 2 would be negative 2x squared, and we'll put that underneath the x squared terms. So multiplying the top number by the term we're dividing by, we have x cubed minus 2x squared. From here, we'll subtract. It's a good idea to put parentheses around the term we're subtracting. X cubed minus x cubed would cancel out, and we'll have 8x squared minus a negative 2x squared. Since we're subtracting a negative, this will actually be adding 2x squared. 8x squared plus 2x squared would be 10x squared. Remembering these steps for long division, after we subtract, we can bring down the next term, which is negative 20x, and we'll repeat the process. Taking the first part of the term, x, we'll divide that into the first part of the term down here, which is 10x squared. Or you can also think what term times x will give us 10x squared. And that term will be 10x, because 10x times x is 10x squared. When doing long division, these first two terms always have to match up. Keep in mind, using the distributive property, we'll have 10x times a negative 2, which would be negative 20x. Again, you can put parentheses around the term that we're subtracting. 10x squared minus 10x squared would cancel, and negative 20 minus a negative 20. Subtracting the negative 20 will actually be adding, and negative 20x plus 20x will cancel. So we'll have 0 or a remainder of 0. And our answer above the dividing symbol will be x squared plus 10x. Next question, and last question for the section. In parentheses, x cubed minus 27 with a division symbol dividing by x minus 3. So again, dividing using variables, we can use long division. Again, we'll set up the long division symbol. Inside the dividing symbol, we'll have x cubed minus 27, but we'll change it a little bit. X cubed will go first. The next term after x cubed would be x squared. There's no x squareds inside this polynomial, but what we can do is add 0x squared as a placeholder. Similar to the first question we did with 101, you have to have that 0 for 101. For all polynomials, we'll have to have all of the exponents. We'll have x cubed plus 0x squared. After x squared, we'll have x. There is no x in the original question, so again we can add plus 0x. And after the x, we'll have the coefficient minus 27. When doing long division, it's very important to have all your placeholders and all of your exponents to get the correct answer. Dividing by x minus 3, we can put outside the dividing symbol. Dividing from here, we'll take the first part of the term x and divide it into x cubed. Or again, what number or what term times x would be x cubed. And that would be x squared. X squared times x would be x cubed. And again, using distributive property, x squared times a minus 3 would be negative 3x squared. Putting parentheses around this term and subtracting. The first term should always cancel out. X cubed minus x cubed will cancel. And 0x squared minus a negative 3x squared minus a negative will be adding 3x squared. So 0 plus 3 will be 3x squared. Dropping the next term down, 0x. Again, we'll divide x into 3x squared. Or what term times x would be 3x squared. And that term would be 3x. 3x times x is 3x squared. And 3x times a negative 3 would be minus 9x. Again, the first term should always cancel. 3x squared minus 3x squared. And 0x minus a minus 9x will be adding 9x. So 0 plus 9x will be 9x. Bringing the last term down, minus 27. X into 9x. Or again, what term times x would be 9x? And that term would be a positive 9. 9 times x would be 9x. And 9 times a negative 3 would be negative 27. Subtracting, if these last terms match up, 9 minus 9 and negative 20 minus and negative 27, we're adding 27. The 0 means no remainder. And our answer will be x squared plus 3x plus 9.